So in our next section, we're going to talk about implementing layer 2 switching in NXOS. And there's not going to be a lot of slides that I'm going through in this section. We're mainly going to be looking at examples live on the command line, so we can see specifically how do we configure the different layer 2 switching options, and then just as importantly, how do we verify that they're actually working, and then what are the different troubleshooting methods that we can go through if we do have a problem in layer 2 forwarding. Now, we'll see from a high-level overview in terms of basic functionality. Nexus switching is very similar to Catalyst switching. We'll see that there are some minor differences in the specific syntax implementation, but from a protocol background or protocol theory point of view, it's basically going to be the same whether we're doing VLANs and trunking on Nexus or Catalyst, or whether we're doing spanning tree on one versus the other. But we'll see that some of the default values are going to be different, and they are going to be worth mentioning as we go through the specific implementation. As I mentioned, the topology that we're going to be using is going to be based on both the Nexus 7K, 5K, and the fabric extenders down to the 2K. And what we're going to start with is a basic example of establishing layer 2 connectivity between two servers that are in the same VLAN over the basic layer 2 switching infrastructure. So up to this point, I have two different servers in our topology we're going to be using, which are specifically server 7 and server 8. And they do have multiple layer 1 connections into the layer 2 switch network. So they're basically a dual uplink to both of the 5Ks. We'll talk about in more detail later specifically why we would do that, and within the case of the virtual port channel. But for these examples, outside of doing VPC, outside of doing Fabric Path, we're just going to look at them using single connectivity, as you would have your normal single attached desktop or your laptop to the wired LAN. So specifically in this case, on server 7, I have a NIC card that goes up to 5K7. And then on server 8, I have a NIC that goes to 5K8. And we're going to be using then the layer 2 switching infrastructure in the middle in order to get basic IP reachability within a VLAN between these two devices. So let's go ahead and take a look at this quickly from the server's point of view. And essentially what I have is just two different NIC cards, or two different network adapters on server 1, or on server 7, excuse me, based on the diagram. So the one on the left. On server 7, I have it configured with the IP subnet 10.0.0/24, and specifically its address is 10.0.0.7. So our ultimate goal, once the implementation is done, is to see that we have just basic IP reachability between the two servers. Now specifically, if you can see what this shows here on the individual network adapter, this particular link is going to port 1 of 5K7. So let's take a look at what this looks like from the CLI point of view. Okay, so right now on 5K7, we have pretty much a blank configuration in terms of the layer 2 switching. So you can see that the Ethernet interfaces basically have just a default config. In terms of comparing Nexus here versus the Catalyst switches, one of the minor differences you may notice is that Nexus normally doesn't have either the shutdown or the no shutdown command there listed as a default. So in most cases, you want to assume that the Nexus ports are disabled, and you will need to issue the no shutdown command in order to enable them. Where in most cases in Catalyst switching, all of the interfaces are up, and the only thing you need to do is just plug the physical ports in order to get basic layer 2 connectivity within a VLAN. But in our case, since these platforms are focused on the data center environment, you normally wouldn't have activated ports unless you go through your change control system in order to say, okay, now I'm finally ready to actually turn up the link that goes to the end host. So in general, you can assume that the ports are going to be turned off. They're going to be disabled. In our particular case here, we're using interface E11. So let's just look at the show interface E11. And we're going to look at just the basic layer 1 properties. And one of the first things that we should notice here is it says the Ethernet interface is down because there is a failure of the small form factor pluggable SFP, basically the optic that's plugged in to the particular interface. Now, as we had briefly talked about before, certain ports on Nexus are single rate, certain ports on Nexus are dual rate. where in this particular case we can see that this link is either a 1 gig or a 10 gig Ethernet. Where in other cases you might have a port being 10 gig only, it might be 40 gig only, it might be 100 gig only. And in most cases, you're going to see that if it is dual rate, it's not going to automatically negotiate what the speed of the link is. Where in the case of Catalyst switches, normally auto negotiation is on. So you plug the port in, whether it's 100 meg, 1 gig, or up to 10 gig, it should automatically detect that. But in the case of Nexus, most of the time it is not going to do that. So in our case here, when we look at show interface status, it looks like there's a problem with the physical link. But if we look at here where it says the speed in the duplex, right now that this is configured as 10 gig full as opposed to auto, which is what you would see on most Catalyst platforms. So in other words, if you do have 1 gig attached hosts, you just simply need to manually set the speed down to 1 gig for that individual port. Now you'll additionally see that not all ports are dual rate. So when you are doing your physical design in the network, it is important to check what ports are going to actually support that configuration. So if we look at the show interface and let's say pipe include Ethernet or hardware, and on this particular box, which is a 5548 UP, ports 1 through 32, these are all dual rate interfaces. But depending on what box you're looking at, like if we jump to a little bit older platform, let's say a 5020, for example, which is the first generation 5Ks, and if we look at the same output, which was the show interfaces, pipe include Ethernet or hardware, we see that on this particular box up to port number 16, these are all dual rate interfaces. After that 17 and beyond on the fixed module, these are all single rate interfaces that are just as 10 gig. So again, just from a physical layer 1 design point of view, make sure that you check the capabilities of the port if you're trying to plug a 1 gig host into that. And if you have 10 gig attached servers, you may not want to necessarily start them at port number 1. You might want to start them at the 10 gig only ports, just in case in the future if you need to have servers that are attached, like legacy servers that have only 1 gig ports. Okay, so what we need to do here then in order to allow the switch to use this port, because we see that it's basically disabled now, show interface E11 status, is we're going to need to go to the port and just manually set the speed. Where if you look at this versus Catalyst, normally you would see the auto negotiation of the speed, but in this case, this particular box doesn't support that, so we're going to have to set it down to 1 gig. Okay, also, if you see this output here where it says the SFP is invalid, there are other potential issues or potential reasons why this might be the case in a real design. And one of the additional things that you can check is to say show interfaces transceivers, and that shows you the physical properties of the actual SFP, of the optic that you have plugged into the port. So if we look at the show interface E11 transceiver, what it tells us here is that this is a 1000 base T, or basically this is a GLC-T, like we were talking about before, the copper 1 gig optic. And the other way that we can tell this, even if we didn't know what the part number is based on the speed of the link. So this says that this is 1300 megabits per second. This extra 300 here is basically the layer 1 framing of gig Ethernet, which is going to allow us to have an effective bandwidth of 1000 megabits per second, or 1 gig. Now, if we were to compare this to some other interfaces that we're using, let's say show interface E110 transceiver, we can see that this is a 10 gig 3 meter copper cable, or in other words, this is specifically a twin-ax cable. And we can see the nominal bit rate, it says it's 12,000 megabits per second, or in other words, 10 gig E, with the additional 2 gig for the layer 1 framing. Now also on this particular box, if we look at the show interface status, and we look at some of the optics or some of the ports towards the end, for example, E129, If we show interface E129 transceiver, this particular port says that the bit rate is 4,300 megabits per second, which is kind of odd because we don't have a 4 gig Ethernet specification. We only have 1 gig, 10, 40 gig, and 100 gig. So what this actually means in this case is that the optic plugged into this interface is not an Ethernet optic, it's a fiber channel optic. Now from a real deployment point of view, from a real deployment point of view, when you physically look at the optics, you really can't tell the difference between what is a 10 gig Ethernet and what is a fiber channel SFP. So if whoever is doing the layer 1 wiring in the data center makes this mistake, you can always check that by looking at the specific transceivers. And in this particular case, the reason why it says that the SFP is invalid is not because of the speed negotiation, it's that it's trying to send layer 1 Ethernet frames out the port, but the transceiver is specifically for fiber channel, which has a different frame format behind the scenes. Okay, but in our case for the 1 gig Ethernet, now that we have the speed set, if we show run interface E11 and show interface E11 status, we should see that the port is now connected. So same thing is going to be true on the other 5K, where this second port, specifically on it, is going to be E12 that is going down to the server that we're using. So let's say show interface E12 status. It says the SFP is invalid, and again, that's because we're running it as 10 gig full duplex. So on interface E12, we're going to set the speed to 1 gig and say no shutdown on the link. Show interface E12 status. Okay, now the port is up. Now, in the case of Catalyst switches, what you would typically see on a lot of the platforms when you plug in the inter-switch links between the Ethernet switches, like if you uplink a Catalyst 3750 to a 6509, depending on the code version, the switch might automatically form an 802.1q trunk link or even an ISL trunk link in order to transport multiple VLAN tagged traffic from one switch to the other. And the way that this is normally controlled is based on the switch port mode of the interface. Now, in the case of Nexus, since the data center environment is generally meant to be a little bit more static than an enterprise network might be, where enterprise you might want the network to be a little bit more plug and play, in the case of NXOS, it does not support automatic negotiation of the layer 2 trunk links. So if we were to look at these interfaces on 5K7 that go towards the uplink switch, which in this case it's the link between 7K7 and 5K7, so these particular ports, and we look at them on the 5K side, let's say show interface E16 switch port, we see that the operational mode of the interface is access as opposed to dynamic, which is what you would normally see on a Catalyst platform. So in the case of Catalyst, a dynamic port means that you're running the dynamic trunking protocol, or DTP, which means that the device on the other end of the link can negotiate whether the port is going to be a trunk or whether it's going to be access. But in the case of Nexus, we do not support that. If we want the interface to be a trunk, we need to manually set the switch port mode. So in our case, there's mainly going to be 3 different types. We have access, which is going to be a single VLAN assignment. We have trunk, which is going to carry multiple VLANs as 802.1q tags. And then our FEX fabric port, which again is the VN tag protocol that goes down to the Nexus 2K fabric extender, or what we would see from the UCS fabric interconnect down to the I/O module in the Blade series chassis. Now for regular layer 2 Ethernet switching, we're going to be using either the mode access or the mode trunk, where the mode access is going to be on our links that go down to the servers. So specifically here on 5K7, this port is going to be configured as access. Same is going to be true on E1, 2 of 5K8, that's going to be configured as access. And then the links in the middle between the switches, these are all going to be where we configure them as trunk links. Now additionally, in the case of Catalyst, where you would normally go to your port And in our case, let's say these are going to be E16 through, so this is going to be E16 through 7 on the 5K side. And we'll say on interface E16 through 7, the switch port mode is going to be a trunk. Now, in the case of Catalyst, normally when you issue this command, it would reject it and give you an error saying that you have to choose what the trunking encapsulation is before you're allowed to statically set the mode to be a trunk link. Or in other words, specifically it's saying, do you want this to be an ISL trunk or do you want it to be an 802.1q trunk? In the case of NXOS, it only supports the open standard, which is the .1q trunking. So you'll also see that there's no command that is the switch port trunk encapsulation. In the case of Catalyst, this is where you would normally choose the difference between ISL and .1q. But for Nexus, we're simply going to say switch port mode is trunk, and that means that we're going to be running both of these ports as 802.1q trunk links. Okay, we can additionally see that there's no filtering on the interface in terms of VLANs. So if we create VLANs 10, 20, and 30, they're automatically going to be flowing over all of the any of the trunk links that we configure. Now, just like in the Catalyst world, we can control this on a per port basis, that I can say VLAN 10 is allowed over one link, VLAN 20 is allowed over another link, and that's how we can do some basic layer 2 traffic engineering in order to send layer 2 traffic one direction versus another. Okay, also as someone had mentioned here, the port aggregation protocol in terms of when we're doing port channeling likewise is not supported. So in the Catalyst world, you have the Cisco specific protocol, which is PAGP, and you have the open standard, which is LACP. In the case of Nexus, it only supports the open standard, which is the LACP implementation. Ultimately, both of the protocols do the same thing though. So when you're comparing ISL and .1q, there's really no design motivation to use ISL over .1q, and the same is true with PAGP versus LACP, the open standard. And in the data center world, you're assuming that there's probably going to be some vendor interoperability, so you generally don't want to use these types of vendor-specific protocols for the inter-switch connectivity. Okay, next let's take a look at the 7K on the other side, which is going to be on ports E227 to 28. Specifically, this is on 7K7. We're going to show interface E227 to 28 status. And we can see that both of these ports are disabled by default. So again, in most cases for Nexus, the ports are going to be off, and then you need to manually turn them on. What can be a little bit confusing, though, is when you look at the running config, and if we show run interface E227 to 28, notice that it does not have the shutdown command. Now, there's a couple different ways that you can resolve this type of issue, where you can simply just go to the link and say no shutdown. Or we can change the overall global default mode for all of the interfaces, which is controlled by the system default switch port command. Now, one of the other useful features of Nexus NXOS as compared to regular iOS or compared to Catalyst is that it gives you the option not only to say show run, but it also gives you the option to say show run all. Where show run all shows you not only the changes that you have made, but it also shows you any of the default values. So where this is specifically useful is if you look at the show run all on the interface level, where in our cases we have interface E227 to 28. And actually I think I might need to say show run all pipe section 2/27. And this shows us basically what are all the default options at the layer 1 port. So in our particular case, this specific line card, the Ethernet 2 module, this is the F132XP, which again is the layer 2 only module. So it means that these ports are running as switch ports, or in other words, they are layer 2. They default to access mode, not to trunk mode. The default access VLAN is 1. If we were trunking, the native VLAN would be 1, and none of the VLANs would be filtered. Okay, we can also see some of the spanning tree options, like the port priority is the default. The cost is auto based on the bandwidth. So what this means is that if the port is 10 gig, versus 40 gig, the 40 gig spanning tree cost is going to be lower, assuming that you're running either multiple spanning tree or you have the path cost method configured as long, which we'll talk about in a little bit later when we talk about spanning trees specifically. Okay, so next, if we look at the show interface, or not show interface, let's say show run all pipe, pipe include system default. Okay, these three options here, the no system default switch port, the system default switch port shutdown, and no system default switch port fabric path, basically what these are controlling is when you boot up the platform and there's no config, do you want the interfaces to be in the disabled state, so do you want them to be shut down, and do you want them to be running layer 2, layer 3, or fabric path routing? In our particular case, with this individual version and the cards that we have, it says that the default mode for our ports is that we're going to try to make them as layer 3. Now, the layer 3 cards that we have specifically in this individual platform, if we look at the show module, again is module number 1, we have line card M132XP inserted. And if we look at then the show interface status, we would see that the M card ports are all trying to run as layer 3 routed interfaces. Or in other words, from a configuration point of view, this is what you would implement as the no switch port command. So then you're allowed to go to the M interfaces and directly configure an IP address. It's going to behave just like a regular layer 3 interface on a dedicated router. And again, this is controlled by that system default switch port, where in this case it's saying don't make them switch ports, we want to make them layer 3 interfaces. Now in the case of the F card cannot be a layer 3 port, so it says for anything else that's left over that is a switch port, we're going to have those ports be shut down. And we can see that's where we get this disabled by default. Okay, the other option, system default switch port fabric path, this would typically be used in a fabric path core switch, where all of the interfaces are going to be doing fabric path routing and you're not running any regular classical Ethernet. So we'll take a look at this a little bit later when we talk about fabric path specifically, but essentially what it's doing is changing the mode of the interface. As opposed to being Ethernet, we're running the fabric path encapsulation. Okay, so let's go ahead and configure all of the rest of the interfaces here as trunk ports. And we're going to do this quickly just by configuring them from an interface range point of view. So on 5K7, we're going to say that on interfaces E1 3 through 9, so basically all of these ports here, we're going to configure these as switch port mode trunk and say no shutdown. Okay, notice also in the case of NXOS, you do not need to use the interface range command. You can simply use either a comma to separate the interfaces or a dash to be inclusive, and you can use this not only in configuration, you can also use this in show commands. Where in the case of Catalyst, we would need to say interface range, Ethernet 1.3 to 9. In the case of Nexus, you can say things like show run interface E1 3 through 9, or show interface E1 3 to 6 brief. So it makes it much easier when you're filtering the output that you can directly reference multiple interfaces at a time. So if we show run interface E1 3 through 9, we can see it as a pretty straightforward config. We're just configuring it as an 802.1q trunk. So same thing on the other side. On 5K8, we're going to say interface E1 3 through 9. The switch port mode is trunk and no shutdown. Okay, on the other end, on the 7Ks, we're going to enable all of the ports here which are on the F module, and then these two ports here which are on the M card. So on 7K7, we're going to say from interfaces E1 25 to 26 and E2 25 to 30, first off, these are going to be switch ports. Now, if I hadn't issued the switch port command on its own and then tried to issue the switch port mode trunk, we should get an error message here that it says ports 25 and 26, it can't make this change. And the reason why is that by default, they're running as layer 3 routed ports. Now, you don't necessarily need to memorize which is the default and how you change it. The quick way to look at this is just to look at the show interface status. And this will tell you, is the port running as routed or is the port running as trunk? Now, if you do have some of the newer modules, like if you have the F3s or if you have the F2Es in a VDC on their own, and assuming you have those default commands, which are the no system default switch port, then those ports likewise would be running as native layer 3 routed interfaces. You can also tell this if you were to look at the show interface switch port. And if it tells you simply that switch port is disabled, it means that this is running as a layer 3 interface. Okay, but in our case, we're going to run these as layer 2. So let's say switch port, and then the switch port mode is trunk, and no shutdown. Okay, same thing on the other side. We're going to say interface E1 25 to 26 and E2 25 to 30. These are going to be switch ports. And the switch port mode is trunk. And the ports are enabled.